Welcome engineers. In this video we are design a corridor lighting system. So, first check our conditions. At the first line, the condition is we need 4 switches and 3 lights. Second, when someone enter from any side of the corridor, and press the first switch, light 1 will be glow up. Third, when press the second switch, second light will be turned on, and the first light will be turned off. Fourth are same, press third switch, third light will be turned on, and second light will be turned off. And at the last when press the fourth switch, third light will be turned off. And this condition work for both side. Open Schematic Manager. Here, already I have created a project file. For your case you need to create a new project file. And also open simulator software. So, to create this logic we need SPDT switch. This is the symbol of the SPDT switch. Here this A describe the common terminal of the SPDT switch. And B is the normally closed terminal. And C is the normally open terminal. Now, let's design the SPDT switch first. I am taking a NC contact, giving I0.0 address on this NC. Now focus on it. To create a SPDT switch, we need a NO contact and a NC contact at parallel. But here, I am taking two pair of SPDT switch. Don't worry, I will explain it clearly. Here, this NC at series of this NO is the second SPDT switch. Take a view on it. This is the series combination of two SPDT switches. So here, I am doing the same thing. Taking two SPDT switches. This is the first SPDT switch. And this is the second SPDT switch. Let's giving address. Let's check, is it work or not? Note, I am align this SPDT at this configuration. Click on Download, to download the logic to the CPU. Now, I am turning on the switch 1. Press at I0.1. Yeah, our light 1 is glowing. Once, check our condition. When someone press switch 1, light 1 glow up. And it is work same. Let's try to understand. When switch 1 pressed, this NO became a NC terminal and this NC contact became a NO. And, due to switch to at-off condition, this NC passes the power flow. And light is turned on. Now, switch to R press, and it is changes their contacts NO to NC, and NC to NO, and it's turned off the light. In simulator section, 1 represent I0.1 and 2 represent I0.2. Now, I am giving tag names. I am deleting the normally closed contact and take a new network for the next condition. Now, at this network, I am taking an output coil for the second light. Let's check for the second condition. When switch S to R press, light 1 are getting turned off. And light 2 will be turned on. So here, we use this second SPDT switch. Let's do this. Take a NO contact and a NC contact at parallel. Click on NO, and before the NO contact, select this line, and add a branch. Then take a NC, and close the branch. Giving addresses. I0.2 for both NO contact and NC contact. Let's start simulator. Here, the second light turns on automatically. So I am taking third SPDT switch in series of second SPDT switch, for which we can control the second light. Giving address. Also giving symbol name. Okay, let's check it. At first, SPDT switch 1, switch 2 and switch 3 are off. So, first light and second light are also at off condition. I think you are all understand this configuration. Let's press first SPDT switch and turn on the bulb 1. Now understand this. When I am pressing switch 1, the NO contact became NC contact, and same with the normally closed contact became normally open contact. Since the SPDT switch is in off position, its NC contacts are passes the power supply and bulb 1 are turning on. Due to switch 2 is off, its NC work as a NC contact and NO as a NO contact. And here is the wiring image of network 2. Now, I am press the second switch. Remember, SPDT is a toggle switch, not a push button. And when S2 is pressed, it turns light 2 on and light 1 off. And it is work same. When I am pressing switch 2, the normally open contact became normally closed contact, and same with the normally closed contact became a normally open contact. Due to NC became a NO, so it's cut the power flow. And in the network 2, I am changed the polarity of the switch 2. Here is the difference between switch 2 configuration in network 1 and network 2. And this configuration are same for the next condition. If I am taking the switch 2 at network 2 as same as the network 1, then it's not work. We need to design like this. Let's jump on the fourth condition. When we press switch 3, light 2 will be turned off. And here is it. The NC contact of the third switch became an NO. And it cuts the power supply and the light 2 turns off. Check the fourth condition. When S3 are pressed, light 2 turned off and light 3 will be turned on. Stop the simulator. And add a new network for fourth logic. It will same with the above logic. So, I am fast forward this. It is done. Let's download the logic and simulate. S3 is on. That's why, third light at on condition. Turn on the fourth switch and it's off the third light. Here output indicator is off. See its work. Turn off all the switches and turn on one by one. First, when someone enter in the corridor and press the switch 1, light 1 turn on. And the person goes forward and presses switch 2, light 1 turns off and light 2 turns on. Again same, the person goes forward and presses switch 3, light 2 turns off and light 3 turns on. And when the switch 4 is pressed, the light 3 will turn off. Turn off all the switches. And check if someone come in the corridor from the other side when all the switches are at off condition. When someone enter in the corridor and press S4 first, light 3 getting turn on. Like this, bulb 3 is turn on. And presses switch 3, bulb 3 turns off, and bulb 2 turns on. Again same, the person goes forward and presses switch 2, bulb 2 turns off and bulb 1 turns on. And at last, when the switch 1 is pressed, the light 1 will turn off. Let's check reverse condition. Press S1 bulb 1 on, press S2 bulb 2 on, press S3 bulb 3 on, and press S4 bulb 3 off. Explain step by step. When S1 are pressed, S1 NO contact became a NC contact and NC contact will be a NO contact. Since S2 is off, then power flow through this normally closed contact. When S2 is pressed, S2 NO contact will be an NC and NC contact will be an NO contact. And it's turned off bulb 1 power supply. But in network 2 it work as same as network 1. Since S3 is off, so power flow through S3 NC contact. And bulb 2 glow on. When S3 is pressed, S3 NO contact will be an NC, and NC contact will be an NO, and it will cut the power flow and turned off the bulb 2. But in network 3 it work as same as first and second network. Since S4 is off, so bulb 3 glow on. And by press switch 4, bulb 3 gets off. Here I have drawn a simple SPDT switch and added a bulb. Here, this is a SPDT switch. And I am add a bulb with the NO terminal, or other side add a bulb with NC terminal. When SPDT switch are press, NO contact change to NC and it's turn on the power. And this simple logic are used in corridor lighting system. Thank you.